What's going on, everyone? In this video, I'm going to be reviewing A Universe from Nothing, Why There is Something Rather Than Nothing by Lawrence Krauss. Lawrence Krauss is a theoretical physicist and cosmologist who, in this book, tackles the topic of how a universe can come from nothing, for example, the Big Bang. Now, I'm not going to pretend to know or comprehend everything that he's saying, so I'm just going to keep it with generalizations of the content that I've read. We can observe the fact that the universe resulted from a Big Bang. And the way that we can tell that is because when we look out into space and we see stars and planets, everything is moving away from us. And the way that we can measure the way that things are moving away from us is by looking at the type of light and the color of the light that is coming back to us when we're observing it. So when we look at stars and planets, the color of the light is increasingly red shifting, which means that the color coming back to us that we can see is moving towards the red end of the spectrum of light. And what that means is red light has a longer wavelength, blue light has a shorter wavelength. So when we see something and it's this red one day, and then we observe something the next day and it's this red, we can see that the wavelength is getting longer and longer and longer. So since the light coming back from us is getting longer and longer, we can tell that things are moving away from us. If you were to reverse time and currently everything is moving away from us. If you were to reverse the clock, then logically it would seem that everything at some point must have been in an infinitesimally small point, which would have been the beginning of the Big Bang. We also know the shape of the universe, and as weird as it sounds, the universe is flat. Not flat in the sense of a piece of paper being flat, but rather it doesn't have a shape or curve that an arch would have or a U-shape would have. He discusses the origins of the universe, the shape, the makeup, everything from the incredibly large to the incredibly small. So here are a few cool facts that I learned while reading this book. Empty space has energy and can weigh something. Many trillions of years into the future, there will be no evidence that a Big Bang ever took place due to things being too spread out and the fact that space itself expands faster than light. It also discusses the topic of why we're here. And as humans, we play with the word why too much. What we should be asking is, how did we get here? And I'm taking this example from Richard Dawkins. He said, you can ask the question, why do mountains exist? Well, it might not have a meaningful answer. What you can ask is, how did mountains get there? We're asking why in the sense of purpose. Just because we can answer, or just because we can ask a question doesn't mean that it deserves an answer. So he gave the example of saying, I could ask you, what is the color of jealousy? Now that question is grammatically correct, but it doesn't deserve an answer because it doesn't make sense. So asking why we are here in the sense of purpose, maybe it doesn't have a meaningful answer and maybe it doesn't deserve an answer. Lawrence introduced a funny moment when he was lecturing at universities about a flat universe, that the types of reactions that he got were mainly smiles and nothing more. So as you can tell by this chart, the shape of our universe is flat. Not flat in the same sense that a pancake might be flat, but rather in this definition, it's because light rays travel in straight lines, as opposed to, okay. And the fact that we only know of one universe doesn't necessarily mean that there is only one. After all, things really don't happen in ones. There's not just one planet, there's not just one star, there's not just one galaxy. Rare events happen all the time. I forget the exact figure that I read in this book, but it was something like once every 100 years, one star in a galaxy will go supernova. But there's 400 billion galaxies out there. So that means that there's 400 billion stars that are going supernova every 100 years. Rare events happen all the time. So our universe might not just be one universe, but a collection of a vast network of universes. A lot of the information in this book does seem to be discussed and gone over in similar types of science books, but it's always refreshing to get a new perspective on things, and I really enjoyed my first read by Lawrence Krauss, so this book gets a 5 out of 5. Thanks so much for watching, and I'll see you guys in the next book review video. See you later.